and safety in agriculture. She is a gold medalist for her PG batch in 2019 at IGKV Raipur. Her PG thesis has been recognized as Best Thesis Award at International Seminar on Modern Agriculture Approaches in 21, 21st Century, organized by Samagra Vikas Welfare Society 2019. She has also been awarded the Best Research Paper Award for Anthropometry of Tribal Farm Women to Improvise Hand Tool Decision for Bastar district of Chhattisgarh at 56th Annual Convention of Indian Society of Agricultural Engineers. So we welcome you, Dr. Puvi. So now it's over to you. So, dear participant, kindly wait for a few minutes. There might be some glitches, technical glitches at the end of our speaker. So, very shortly, she will be with us.
Hello, am I audible?
Yes, ma'am, you are audible.
Okay, thank you
Yeah,
so
Dr. Purvi, you are very much audible. Just kindly share your screen.
Is the screen visible?
Yes, ma'am.
Okay, thank you. So, very good evening to everyone. Sorry for the delay. Myself, Dr. Purvi Tiwari, currently working as a Senior Research Fellow in ICR CIA, that is the Central Institute of Agriculture Engineering. I am over here to deliver a training on drone technology in agriculture as per the International Training Program on Agriculture Innovation and Technology. As we can see, the agriculture technologies are enhancing day by day. And we know in a limited land area and limited time period, to produce anything from the field, it is very arduous because we have to manage time, we have to manage resources, and we have to manage all the not only the resources, but all the climatic factors also we have to consider. So for that, we have to switch towards smart agriculture technologies, in which prominently currently we can see drone technologies are in the means mostly discussed right now. And it is already being used in other departments and like militaries and all. But in agriculture, its exposure is recently being focused. So what is the current scenario? We can see how the generations are being, all the human population is growing day by day. And to feed that much population, it is very tough to feed 815 million people every year. So we can see how the hunger index will increase globally. And it is also being noticed by FAO that currently agriculture production level need to rise up to 60%. As the population is growing, we have to increase our agriculture produce. And by IPCC, that is inter panel, that climate change warns that the crop yield may decrease by 10 to 25% due to climate change by 2050. As we know how the environmental degradations are occurring day by day because of excessive use of fertilizers, or excessive use of machineries are also being harmful for the environment, as fossil fuels are required to burn the and run these machines. Therefore, we are switching towards the no tillage operation or minimum tillage, so that number of runs of these machinery can be reduced, and the dependency on the fossil fuels can be reduced. So this is also a major concern about the climate, how we can produce agriculture production by climate resilient approaches. So new emerging farming techniques, we can say, like unmanned aerial vehicles, or commonly known as drones. So we have to switch our traditional farming towards smart farming. Now, what is drone? It's common thing. What is drone? It's a dynamic, remotely operated navigation system. Means if a person wants to operate any, to perform any operation in the field by his room, we can do it by just by a mobile network and mobile application. And we don't have to properly manage all the things. And by sitting only in one seat, we can apply anything like spraying. We can monitor the crop within the room. If we don't want to go to the field, but we can operate anything, and we can monitor step by step each and everything. Therefore, it's a dynamic, remotely operated navigation equipment. It can be controlled directly by the operator through a radio link, or various levels of autonomy achieved by using autopilot technology. For this, we have to also currently so many schemes are running to learn how to operate this, and we can get the certificate of the autopilot technologies also. Looking into the background of drone, how these have came in agriculture. Earlier, they were not used in agriculture. It was used in military and civil surveillance and all these things. In 1980s, use of drone in agriculture was undergone rapid evolution. In 1983, remote control aerial spraying system was introduced, and it was only for agrochemicals, and that was in Japan. And in 2000, facilitated a broader adoption of drones in agriculture sector. And we know that earlier, currently also it is being used in military and civil surveillances also. And in 2006, FAO introduced first commercial drones. In India, in 2018, India have an Indian drone policy was introduced, and 35 drone startups was released. So this, we can see how we are emerging a new technology, how these drone technologies are being emerged day by day. What kind of drones are being used, and what kind of drones are there in the industry except agriculture? Based on the form, features, and functions, these are fixed wing drone, single rotor drone, multi rotor drone, and hybrid drone. Fixed wings means जो wing होगा, that are fixed, they are not flexible one. Single rotor means it will have only single propeller. Multi rotor means number of rotors and number of propellers, like that. For lifting the drone, we need rotors. For single means single propeller होगा, और multi में number of होंगे, more than 2. And based on maximum takeoff weight, like nano, micro, small, medium, and large. These can be like small, micro can be incorporated in greenhouse for monitoring of the insect pest and the growth of the crop, so that we don't have to go inside the greenhouse. As working inside the greenhouse is also very arduous, because inside the greenhouse, if we emit any pesticide in a confined area, that if a farmer will inhale that air, and it will be very problematic for the farmers to breathe inside. Therefore, if a farmer want to operate or want to insert any pesticide without inserting inside the greenhouse, they can use small drones for doing this. Pesticides can be incorporated by using the small drones. And according to Watts, micro air vehicle vertical takeoff and landing, low altitude short endurance, and low altitude long endurance. And last one is the medium altitude long endurance. Now further we will see how these drones, a variety of drones. Fixed wing drones, this you can see, this is this kind where the wings are very fixed and no, these don't have just have a single propeller to lift. And its pros are it covers efficiently large area with longer flight endurance. And what it cannot do is it cannot hover, and it cannot maintain above ground level, and it requires an open area for takeoff and landing, because its wings are very fixed. Therefore, it's having so many disadvantages for agriculture. And a rotary wing, there's a helicopter and multicopter. These are very efficient because their sizes are very big, and you can see it can operate at an airspeed of 0 to 54 km/h. And multicopter means it's having so many propeller. 4 propellers it comprises of 4 propellers, and this is also very user friendly and it's very efficient in work. And last one is the hybrid wing. It combines vertical takeoff and landing with fixed wing efficiency, adaptable to various terrains. Now further, we will see the components of drone. Main components of the drone is sensor. If a sensor is just like a brain for the drone, it comprises of silicon-based sensor. It will have a camera system, video system, and scanner. Okay, so what will happen to scan anything like insect pest in the field, in the running crop? We need some camera system and video system to identify the pest or weed or the moisture level in the soil. We need sensors to identify that how much water level is there or moisture level is there in the soil, or kind of pest or what kind of nutrient deficiency is occurring in the plant. Okay, so first we can see that this is the flight controller and sensor. Okay, and this one is the BLDC motor arm, where main function of this this will propel this propeller. Okay, this is the fluid hose pipe. This is the BLDC motor. Okay, with this motor arm, the motion will go to the propeller. And this is the nozzle, from where the flat fan nozzle, from where the all the spraying material, agrochemicals are being emitted. This is the pesticide thing, where all the pesticides or weedicides can be added over here in this tank. This is the landing gear, means when the drone will set down in the land, this is the landing gear. This is the foldable propeller, and this is the battery. Okay, so this is the main components of the drone. And now we will see how the drone system works. This is the main drone system. Here we can see these 4 propeller drone. Here we can see the battery is over here. From here, all these things are connected with autopilot mode, where all the sensor will transmit the after assessing the video, it will transmit to all the autopilot mode. That will tell to the autopilot mode how much we have to spray the chemicals to the crop or nutrients to the crop, or what amount of irrigation water should be given. In this way it will work, and all the sensors are being incorporated, which will provide the autopilot mode to work accordingly. And with this all Wi-Fi's modern systems, all these videos being recorded, and it will detect how much it will detect if it is a weed, if it is a pest, it will detect by a camera system. Like now we will see the type of drone mounted sensors. First one is the RGB, that is red, green, blue camera system. It will capture visible light, and that is the red, green, and blue are the visible light. It will capture and provide high resolution color imagery. This is also called as visible sensor, visible camera sensors. Its limitations are that it will only work in daylight, not in the night. Second one is the multispectral camera. It will capture data across multiple spectral bands, aiding vegetation, identification, and classification. Multispectral means it will identify other ranges of visible light. Like so many spectrum you have observed, infrared, X-rays, and visible light range. So it will also identify except the visible light. So it can run in night also. IR camera, that is infrared camera, it detects the infrared radiation for identifying the temperature. For identifying the temperature now, if how the drones will identify the moisture level in the soil, so by the temperature differences. So for that, it is required to be infrared. It is required, this sensors are required, infrared radiation, because it will identify the difference in temperature. But its limitations are that it cannot detect the geological feature directly. Might limited spatial resolution only. It is only for the temperature, water or water area, that resources where these are available. This can be this IR sensors will identify. Now, this is the SAR that penetrates through clouds and darkness, providing all weather and day-night monitoring. And last one is the LiDAR that measures the distance using laser pulses, creating 3D terrain model. This is the laser identification sensor. This will emit a certain kind of laser light, and it will hit back from that object. After that wavelength of hitting back of the object will tell the distance, how much that particular object is, and that will provide you a 3D terrain model directly. Now, what are the uses and advantages in agriculture of drone? Why we are approaching towards drone and why we are approaching towards smart agriculture technologies? Because currently we can see all farmers are small and marginal farmers. 85% are small and marginal farmers. They require small equipments to run and to perform their field activities. So for that, drones are the best option for that. And we can see farmers apply so much of chemicals and fertilizers. So we can see that after identifying perfect identification of the application, how much is required by the plant. So this is called a precision farming. This is the concept of precision farming, that certain amount is being employed in the field after identifying what is the use. Means if it is requiring 10 ml of maybe it's agrochemical, so but farmers are applying 20 ml. So this can be avoided by using drones after perfect identification. And we can also have like weather glitches can be such as if we are using a less amount of irrigation water by the drones, we can apply. And and we can also identify the crop health. Yeah, that how much a crop is being attacked by the pest or any insect, that crop health can be identified or crop surveillance can be done by this drone technology. And livestock management, we can count the livestock, how many live means cattle are there, what kind of diseases are there occurring to them, and what kind of sizes are there. All can be done with this drone. And next is the soil and field analysis. Soil, earlier I also told like how moisture level or nutrient level, by the difference in color and temperature, it can identify the level of moisture and what kind of nutrients are in deficiency, as these field color and plant color will change if there is a deficiency of certain kind of nutrients. It will identify if there is a change. And it is also being used for plantation. How we can have seen the cargo that is containing the that is called the tank. In that tank, all the seeds are being incorporated, and like in very forest areas, the seeds are being sown by the drones. And crop monitoring can be done, how much that seed emergence have occurred, how much seeds haven't emerged. These all can be done by the drone. Now, how the image processing is done in drone. Image processing in drones are the main concept is orthomasking. This is this stitching of the two or more images. Drone will take so many images, but to give proper structuring, this will merge all the images. The structure from motion photogrammetry to align aerial images, and it will stitch the larger seamless image and produce a point cloud or a 3D image area. Now we will see a video.
Multispectral cameras with optical elements, sensor, ratings, and lenses. The light enters the camera through the seat. Prism and ratings refract. The light scan sensor can then generate the multispectral image line by line. Now there are also sensors with batteries integrated into the sensors. Paired with the other scanning types, cameras with spectral filters or sensors have no optical parts but are alignment. They can capture objects with different wavelengths in one sync. So, with a multispectral camera flies above the field collects the image data. The data is then wirelessly transmitted to a computer on the ground. The farmer sees the data on a computer in different colors, for example, red and green. If the red area are single bands, the farmer knows which precise areas need to be sprayed with pesticides.
Okay, we have seen how the image processing was done in drones, how the ortho masking was done, and how the all those different kind of images were incorporated. Now, how the in the field, how the yield estimation is done. Here we can see the imaging drone. This is the drone of imaging and drone with RGB camera. This is a visible light camera, right? Okay, red, green, blue camera. Okay, it has identified the orange color, and here it has the data has been annotated, and after annotation, fruit detection output is given, that how much fruits that the plant is having and how much size it is having. So in this way, the yield estimation is done by the drone. Another one is the normalized difference vegetation index. It will show the difference between the light reflected from the plant and near infrared light. Okay, the healthy leaf will have an active photosynthesis process. So it will absorb red light and strongly reflect near infrared light. So the difference of reflection will be identified with the drone, and it will show how the NDVI, that is the vegetation index, is there. It is for vegetation assessment. Okay, so we will see how through the drone it can be done.
Spread of digital technologies in farms has led to an increasing use of vegetation indices, such as NDVI. Vegetation indices are calculated from data collected using drones or satellites. Commonly used satellites have regular acquisition intervals, such as 5 days or 16 days, so indices are available for multiple dates in the same season. The sun emits radiation with different wavelengths and frequencies. Vegetation absorbs solar radiation in different bands, that is in different frequency ranges and wavelengths, and emits a different percentage of it back into them. The most used vegetation index is undoubtedly the Normalized Difference Vegetation Index, NDVI. It describes the bigger level of the crop, and it is calculated as the ratio between the difference and the sum of the refracted radiations in the near infrared and infrared. The interpretation of the absolute value of the NDVI is highly informative, as it allows the immediate recognition of the areas of the farm or field that have problems. The average NDVI of a field varies according to the variety and phenological stage of the crop. Normalized Difference Water Index, NDWI, reflects moisture content in plants and soil. Vegetation cover on the Earth's surface undergoes severe stress during a drought. If affected areas are not identified in time, entire crops may be damaged. The early detection of water stress can prevent many of the negative impacts on crops. Remote sensing of land and the NDWI index can control irrigation in real time, significantly improving agriculture, especially in areas where meeting the need for water is difficult. The high NDWI values correspond to high plant water content and coating of high plant fraction. Low NDWI values correspond to low vegetation content and cover with low vegetation. During periods of water stress, the NDWI rate will decrease. The NDWI index for assessing risk of fire is used to determine the presence of moisture in vegetation cover. Higher NDWI values indicate sufficient moisture, while a low value indicates water stress. Normalized Difference Range, NDRE, is an index which is sensitive to chlorophyll content in leaves, variability in leaf area, and soil background effects. Chlorophyll content helps us in determining how green a leaf appears. High values of NDRE represent higher levels of leaf chlorophyll content than lower values. Soil typically has the lowest values, unhealthy plants have intermediate values, and healthy plants have the highest values. NBRE is a better indicator of vegetation health than NDVI for mid to late season crops that accumulated high levels of chlorophyll in their leaves. Now you know about NDVI, NDRE, NWA. Let's do a small assessment. What are the different numbers on the next slide?
Okay, so we have seen how the normalized different vegetation index and water index can be obtained through drone. The difference between the like the indexes and the color of the plant will provide the that value. This will lie between -1 and +1, and this will provide the exact value of the how the plant is healthy or stressed. It will be given. Now, we can see how the drones are being applied in our agricultural field. First and foremost thing are the precision farming. For soil health scanning, weather analysis, for monitoring of the crop health, and planning irrigation schedules and estimating of the yield. So far, we have discussed all these points, how soil health can be scanned by the difference in the moisture level, by the thermal sensors, it can be done. And how the weather analysis, this was also being done by the thermal sensors, and monitoring of the crop health, how these disease attacks or pest attacks are being observed by the drones, and irrigation schedule, like which part is having less moisture soil, or which part is having more moisture soil, where can the water logging be occur. So all this can be planned, and accordingly irrigation can be given to the plant. And last one, we have seen how the yield estimation is being done by the identification of the crop color. It will count the amount of that color, and through that we can obtain this much amount of yield is being produced. And soil and field analysis, all the precise 3D maps for early soil analysis can be done, and it will provide how irrigation and nitrogen level in the soil, and how we can manage by applying it.
Are now farmers' new best friends. Imagine soaring above the field.
Now we are seeing how soil and field analysis is being
Today,
done.
we're diving deep into how drones are revolutionizing agriculture, specifically through soil analysis. Why should you care? Because what happens in those vast stretches of land directly impacts your food, the environment, and the future of farming. Let's unpack the marvel of drones in agriculture and how they're not just flying cameras, but powerful tools for precision farming. Have you ever wondered how farmers make decisions about what to plant, where, and when? It starts with the soil. And now, drones equipped with advanced sensors are taking soil health analysis to new heights. First off, what exactly is soil analysis with drones? Imagine a drone buzzing over a field, equipped with special sensors that scan the ground for moisture levels, types of soil, and even pests or diseases. This isn't science fiction. It's happening now, and it's transforming agriculture from guesswork into precise science. Farmers have always analyzed soil, but traditional methods are time-consuming, labor-intensive, and often imprecise. With a drone, a farmer can analyze a 100-acre field in the time it would take to manually sample just 1 acre. But how accurate is this? Thanks to advancements in sensor technology, incredibly so. These aren't ordinary cameras. We're talking about multispectral imaging, which can see beyond the visible spectrum, detecting changes in plant health before the human eye can. So, what's the process? First, a drone pilot sets a flight path. Next, the drone takes off, scanning the fields with its sensors and collecting data on every inch of soil. This data then gets analyzed, providing the farmer with information on where to allocate resources like water, fertilizers, or pesticides. And the benefits? They're huge. Increased crop yield is the big one, as precise soil analysis leads to healthier plants. Then there's water conservation. Knowing exactly where water is needed reduces waste, crucial in regions facing water scarcity. And let's not forget time savings. What used to take days days now takes hours, freeing up farmers to focus on other tasks. But it's not just about individual farmers. Precision agriculture reduces the runoff of chemicals into rivers and streams, protecting our ecosystems. You might be wondering, great, but how do I get started? This is where Drones Tech Lab comes in. We specialize in providing drone services for agriculture.
So far, we have seen how it can manage the soil and nutrient level and irrigation levels in the soil. Now, how the drones can be used for planting. Seed dispersing software is mounted in this quadcopter, and through that and at precise height, this will drop a seed, and that seed covering will be dissolved in the soil, and seed will emerge. And now we will see how the drones can be used for planting purpose.
To fight deforestation. Oxford-based startup Biocarbon Engineering is planning to fight industrial deforestation by planting 1 million trees a year using drones. Drones used by Biocarbon Engineering would first fly above a selected area, map its level of deforestation, and then report its potential for reforestation. After that, automated planting drones carrying seed pods would fly 1 to 2 meters above the ground, following a predetermined planting pattern, and fire germinated seeds into the soil. Small pressurized canister would provide the necessary propulsive force for the seed pods to easily penetrate the soil surface. Seed pods filled with nutritious hydrogel to reduce impact forces on the seedlings during planting would then break open upon impact and allow the germinated seeds to grow. One drone can plant 10 seeds per minute. With 2 operators controlling multiple drones, 36,000 trees could be planted in a single day. Biocarbon engineering system is not as good as hand planting, but it's much quicker and less expensive than traditional planting systems. Follow us down the rabbit hole.
So we have seen how drones can be used for incorporating the seed into the soil. Now, it is also being used for seedling emergence assessment. It will identify the original image from UAV, that is an unmanned aerial vehicle, and all the photographs, that is image processing technique, that is orthomosaic. It will be processed. Then after that, this is the subsample. Subsample will have the coverage of subsample, like this yellow color is showing the area of the greenery, and this yellow color, that is this is the visible range of this color. Then after that, it will show the seed emergence uniformity. Here, this is lighter in color, therefore the seed haven't emerged properly in this area, and this is having a darker color. This shows the seed emergence, or the density of the crop is more. And in this way, we can see this kind of photographs are being generated in the drones. And here, by this method, the grain yield can be obtained by the drone. In the same way, weed mapping can be done. That will identify the weed density by using the vectorized weed and crop cover maps. We will see how e-weeding can be done by the drone.
Weed detection is an important aspect of farming, as weeds can compete with crops for resources such as water and sunlight, leading to reduced crop yields. Traditional methods of weed detection involve manual labor, which can be time-consuming and costly. However, drones equipped with thermal imaging cameras can quickly and efficiently detect weeds in fields and identify areas that may need to be treated with herbicides. Thermal imaging cameras work by detecting the temperature of objects and can detect small differences in temperature between weeds and crop plants. Weeds typically have a higher surface temperature than crop plants, as they are actively growing and absorbing more sunlight. This makes them stand out in thermal images, making them easy to detect. Drones equipped with thermal imaging cameras can fly over fields and take thermal images, which can be used to identify areas of the field that are infested with weeds.
So far, we have seen how e-weeding can be done with the help of a drone. With the help of a drone. Here we can see by the difference of the thermal, with the difference of the thermal differences, the weed can be identified. As we know, for weeding, 300 to 315 man hours are required manually. But by the drone, it is very simplified in a vast area. And we have seen how this weeding can be done. And further, we will see how crop health assessment is being done. This is the disease, this will do disease surveillance, how the plant structure have been changed, the colors have been changed. One of the most devastated attack was done by the locust, as we know, it was in 2001. So the drones were the only solution for killing all the locust attack in the Rajasthan area. And all the monitoring was also being done with the help of drone. Now we will see how the weed imagings are being done by the drones. And we can see this is the drone in a particular path it is running. And here it is identifying the weed. Difference in the color we can see of the weed in the crop. It is identifying these are the weeds. These are the images being produced by the drones. And after identifying this weed, it is spraying weedicide on that weed so that weeds can be killed mechanically. Now we can see a systematic path of the drone, how these drones are being running in a systematic path. Okay. Now drones can also be used for how livestock monitoring is done. Here we can see the different colors being tracked for the any livestock. And here we can see the livestock counting is being done by the drone. And next is the water stress detection. How the water stress detection can be done. When the plant becomes dehydrated or stressed, leaves will reflect less NIR, that is infrared, non-infrared lights, but the same amount in the visible range. So this is used to detect the water stress. Here we can see the images, difference in the images, how the difference in the images are giving the stressed area and non-stressed area. Now we will see how water stress detection can be done through the drone.
And these drylands cover about 41% of the Earth. And unfortunately, they're facing some serious challenges with water availability. To meet the growing demand for food across the globe, we must be smart about how we use our water, especially in areas prone to drought. It's for this reason monitoring plants for water stress is so crucial. It helps avoid damage to crops and prevents losses when it comes time to harvest. Water stress is a critical factor affecting wheat production, especially in regions prone to erratic rainfall patterns or facing water scarcity. Water stress occurs when the demand for water exceeds the available amount or when poor quality restricts its use. When wheat plants experience water stress, their growth is hindered, leading to reduced yields and compromised grain quality. Traditionally, farmers relied on manual observation methods or satellite imagery to assess crop health and identify areas of water stress. However, these methods often lack the precision, cost effectiveness, and timeliness required for effective decision making. Thankfully, drone technology can step in to give us a hand. Drones equipped with RGB, LiDAR, multispectral, near-infrared, and thermal sensors offer farmers unprecedented capabilities for monitoring crop health and
detecting early signs of water stress. By flying over wheat fields, drones can capture high-resolution imagery and collect vital data such as digital elevation, surface, and rain models, which help farmers understand the different features of the earth beneath their crops. This data is extremely helpful for understanding the elevation effects of drainage on fields. Drone data can also be used to create crop water stress index maps, allowing for the assessment of spatial variability in water stress across a variety of crops. Did you know the US is the world's fourth largest wheat producer? In fact, in places like Kansas and North Dakota, drones are already monitoring fields, giving farmers the information they need to make informed decisions. This means farmers can see where their crops need water most, and they can alter their irrigation accordingly. But the research isn't just staying in the US. Teams like the ones at Kansas State University's Feed the Future Innovation Lab are working on this tech and sharing it worldwide. They're looking for wheat varieties that can handle Earth's rising temperatures, fight off disease, and still produce plenty of food. This is important research, especially as our global population heads towards 9.7 billion people. As climate change continues to put pressure on agricultural production worldwide, the adoption of innovative technologies like drones becomes even more important. The ability to precisely monitor water stress levels in wheat crops enhances productivity and promotes sustainability by minimizing water waste. As drone technology advances and becomes more accessible, its integration into farming practices holds the promise of revolutionizing the way we grow food. By harnessing the power of drones for water stress monitoring, all farmers can navigate the challenges posed by climate change and ensure a more secure and sustainable future for their crops. In fact, the American Farm Bureau Federation estimates that farmers could see a return on investment of agricultural drones of $12 per acre, and $2 to $3 per acre for soybeans and wheat. If you like this video, give it a like and share it with your colleagues, and consider.
So we have seen how water stress detection is being done by the drones. It will help farmers to not rely on the irrigation, and it will give the plants not to be get dehydrated, or the waterlogging condition can be avoided if it is earlier detected by the drones. Here we can the farmers can also plan how the plantation should be done according to the farmer's field water level. So we have seen how drones can be so beneficial to the farmers if they are using it. Now further we will see how to operate manually in the field by the remotes. We can see the one of the app for operating this drone, and this is the remote. All the real-time data can be recorded by the drone. Here we can see how the path is being identified. Early only path is defined, how the drone will move in that particular path.
कश किया हमने फ्लाइंग स्पीड 1.5 तक हम रख सकते हैं पीडीएम हमने रख पीडब्ल्यू हमने सिर्फ पंप की यूसेज है वो मैनुअल है लेकिन इसको ऑटो करेंगे 30 लीटर्स पर हेक्टेयर स्प्रे करेगा पर हेक्टेयर साइड स्पीड 1.5 कन्फर्म कैप्चर कर लिया टेक ऑफ एल्टीट्यूड 5 मीटर्स स्टार्ट अब वो खुद ही फ्लाई करेगा और खुद ही स्प्रे करेगा
Here, the operator has already defined the path, and now we can see how this drone is moving in that particular path. And it is spraying automatically.
0.3 लीटर्स के हिसाब से स्प्रे करता जा रहा है वो अपने पास पे होगी उधर जा रहा है जाता है ट्रैक स्प्रे कर दिया है अब उसे कवर कर रहा है क्योंकि उसने स्प्रे कर लिया अब इसको मैनुअली फ्लाई करके मैं वापस ला रहा हूँ 1 पॉइंट वैसे भी ला सकते हैं लेकिन मैं मैनुअली ला रहा हूँ अब ये वापस आ गया वाटर स्प्रेइंग का इसके अंदर एक और पोटेंशियल का ये दूसरे अब सबसे पहले ड्रोन को हम ऑन करेंगे ये ड्रोन टेक ऑफ है अब वो कवर कर रहा है सबसे पहले पॉइंट टेस्ट चेक करेंगे आप पॉइंट ए सेलेक्ट हो गया ठीक है स्प्रे विद 5 मीटर फ्लाइंग स्पीड 2.6 कन्फर्म अब ट्राई करूंगा मैं मैनुअली स्प्रे करना चाह रहा है ठीक है स्प्रे करना जा रहा है इधर तक आ गया अब ये हो गया पॉइंट क्या करो ध्यान तो चेक किया पॉइंट बी अब देखो उसे पूरा हमें फ्लाइट पाथ दे दिया ऑटो फ्लाइंग में ये ऐसे स्प्रे करेगा ठीक है अब हम स्टार्ट प्रेस करते हैं तो यहाँ से खुद ही उसे स्प्रे करता है अब देखो अब इस फ्लाइट पाथ से वो ऑटोमेटिकली फ्लाई करके स्प्रे करता जाएगा ए टू बी ऑटो फ्लाइंग करेगा देखो आ गया इस पॉइंट से अब अपनी लाइन चेंज करके दोबारा शुरू दूसरे पॉइंट पे अब इस सीक्वेंस में स्प्रे करता जाएगा ये इजी मेथड है इसको स्लाइड प्लान के बगैर अप्लाई कर देगा ठीक है फिर एंड कर दो यहाँ पे ओके और ये उधर ही रुक गया ठीक है एंड सक्सेस और वो ग्रीन पाथ नजर आ रहा है जिधर जिधर ये स्प्रे कर चुका है
Now, we have seen how the path already being defined by the operator and how the drone was functioning in that particular path without any middle interference of the operator. This is the drone simulation platform which is being developed in ICRCI Bhopal. Here, all the this is being done for developing the BIS standard for drones, And this is a simulation platform where it will identify the number of crops and for testing the drone. And because recently we are all performing so many research for optimizing the height of the drone for broadcasting, for detection of the weed, and for the crops identification of the yield for the crops like small structure like wheat and millets. So for that research are being going, and for that drone simulation platforms are being have been developed in ICRCI. And some what are the initiatives being taken in India for adopting drones? One of this is the National Drone Policy, which was signed in 2021. It is a simplified regulation for drone uses, and the categorization is based on the weight of the drone and know how the drone because drones we need some regulations for flying the drones, that in no fly zone, and all the safety protocols are being issued by given by this national drone policy. And one of the scheme is the Kisan Drone Yojana. Government support have been given, means if it is of 10 lakhs or 40% subsidies are being given by the government, and for using, and the purpose is fixed of the drone, that is it will be used for pesticide spraying, crop monitoring, and irrigation optimization, not any other, because it will hamper the safety issue. Okay. And one of this scheme is Drone Shakti scheme. This is the promotion of drone across industry, and it will establish a drone training institute and new startups for introducing new drone technology. So far, the schemes which are being adopted in India currently, and we will see a full tutorial of how these drone being used in the field.
So this channel one for roll movement, roll right, roll left. Channel two for pitch forward and backward. This channel three for throttle increase, throttle decrease, gaining altitude and losing altitude. Channel four for yaw right and yaw left.
This is the real-time image which is being captured by the drone. And you can see the path motion of the drone.
AB point mode, also known as auto boundary point mode. It is one of the features in most of the agriculture sprayer drones. It helps in defining the boundaries of the field for spraying. It allows the drone to autonomously follow a predefined path with accuracy and efficiency.
This is the AB mode, where it will allow the drone to move in a automatically in a specific path, that is a straight line or between the 2 points.
auto mode in agriculture spraying drones. The bus that allows the drone to autonomously navigate along a predefined flight path for spraying. This mode enables the drone to follow a specific route, ensuring consistent coverage of field and optimize spraying efficiency.
Here we are defining the path and area to where we have to spray so that it can automatically spray in that particular area without any extra spillage. Now here we can see the path is being defined in different way. And you can see the obstacle was already added so that the drone was moving out from that obstacle. So in this way, the all the limitations, like if there is the obstacle, if there is not the plantation, these all have been reduced by this. While spraying with tractor or manually, these obstacles cannot be avoided. We have to move either from this way or that way, but with the drone, so precisely the path have been defined along with the obstacle. Now we will see the auto route mapping with the flight GPS. This was the mapping method. Okay. Drone mapping was done. So we've seen all the parts of how the path identification was done, how mapping was done, and how A to B mode was operated by this drone, and how the path was allocated, and how the drones were moving in that particular path. Now, after seeing all these things, it's not essential to tell the benefit of the agriculture drone, but it's like we have already observed, it will increase the farmers yield because already surveillance will be done, and all the nutrients, pesticides and water will be given in an efficient way, precise way, therefore the yield will be more. And quick decision making by the farmers, like if farmers have already have the knowledge about the irrigation, how much irrigation has to be given, so they can plan the crop, which crop should be planted in this particular area, and how much irrigation water should be given in that crop, that can be done. And drones are easy to maintain, uh, less maintenance is required, and it will help save water and other agriculture resources like fertilizers and pesticides. No excessive use of all the agrochemicals or biocides are being done, and only precise amount of which, with whatever amount is really required, is being incorporated in the crop. And it will help connect the evidence for the insurance for the crop failure if the proper mapping is being done by the this, which is not practically possible by the farmers to have a proper capturing of the field data and all the photographs, how much crops they got damaged by the pest or naturally by climate changes. This can be done by the drones, and farmers can claim for the insurance if the crops has been failed. And 99% accurate crop and field data gathering can be done from the drones, and allocation and efficient farming can be done with the help of drones. But some challenges are also being faced by the use of this drone, as suitable proper training should be given to the uh, like drone pilots have been assigned. A proper skill should be provided to the drone pilots. No other people can operate the drones, not normal farmers cannot operate it, and lack of suitable and cost effective and lightweight sensors are not available, and these are not cost effective even though subsidies are there. But so many parts are so costly to if they get damaged, normal farmers cannot afford that. And there are very limitations for like so many limitations are there in the specific area. Drones cannot be used if the farmer is staying over there, so they cannot use that drone in that particular area. Algorithm need to develop for each and every plant diseases. It is very hard to develop different algorithms for different plants diseases, even for the pest, even for the weeds, and or even for the nutrient. Different algorithms have to be developed to identify that particular disease or weed. And there are so many limitations between as we have seen, between two rows that drones are being operated and weeds were identified, but between the crop, means crop to crop, it's very hard to identify the weed or the soil conditions, as the canopies are very near, and that locomotion of the drone is very hard between the crop. And certain sensors work at night, so that is a major limitation if we want to get the surveillance in the night, so we can't have, because in greenhouses night surveillances are also being done, how the plants are behaving, and that monitoring cannot be done because some sensors do not work at night. So these are the limitations. If good things are also there, but bad things are also there if we are using drones. But majorly uh, profit is more on using these drones. So thank you, and maybe this session was valuable for all the listeners.
Yeah. So thank
can
you,
end.
Dr. Purvi. So now the session is open for discussion. So whomsoever is just have any query related to the drone application, they may interact with our speaker.